Now that we have a general sense for what elasticity of demand is, and also the determinants of elasticity of demand, we can start thinking about measuring elasticity precisely. So, how do we do that? Well, one way you could think about measuring elasticity of demand is just to calculate the slope of the demand curve. But that's got some technical weaknesses that I'm not going to go into in this lecture. The way that economists measure elasticity is a bit more complicated than measuring the slope. The definition for demand elasticity is given here. So, demand elasticity is the absolute value of the percentage change in the quantity demanded divided by the percentage change in price. And that is written out in a formula here. So delta here, these triangles, delta, that represents change. The percent sign means we're looking at percentage changes. And what elasticity of demand, when you're calculating it precisely, what you're looking at is the ratio between how quickly quantities are changing and how quickly prices are changing. And this is a bit of a spoiler for later on in the lecture, but basically you're going to be interested in whether or not this is greater than or less than 1. So if this number is greater than 1, it tells you quantities are changing faster than prices are. And if this ratio is less than 1, that tells you that it's prices that are changing faster than quantities are. One last thing to note here is the absolute value bars. The reason why I calculate this as the absolute value is because a demand curve is downward sloping, if the percentage change in quantity is positive, then the percentage change in price is negative. If people are buying more, the price is falling. Or the reverse is also true. If the percentage change in quantity is negative, then the percentage change in price will be positive. If quantities are falling, if people are buying less, it's because the price is going up. The good is getting more expensive. So this ratio on its own is always going to be a negative number. So economists will sometimes just take the absolute value to calculate the elasticity of demand. Now, just as a warning, your textbook kind of goes back and forth between looking at the raw calculation and looking at the absolute value. But for the purposes of lecturing, I'm going to always treat it as a positive number. All right. Now, one thing to note is the larger this ratio is, the bigger the number that pops out when you calculate those two and divide. The more elastic demand is, the more responsive consumers are to price changes. So if this is a really big number, like, I don't know, 5 or 10, that would tell you that consumers are very responsive to changes in demand. An elasticity of demand equal to 10 would tell you that a 1 percentage point change in price will generate a 10 percentage point change in quantity demanded. Okay? That would be a quite elastic demand curve. On the other hand, if this number is small, like let's say 0.5, that would tell you that a 1 percentage point change in price only generates a 0.5 percentage point change in quantity demanded. And that's going to be a more inelastic or steeper demand curve. So let's go through an example of actually calculating elasticity of demand. I've got a demand curve here with 2 prices and 2 quantities. The prices are $80 and $40. The quantities are 5 units and 13 units. Okay? Don't look too carefully at this graph because then you'll notice that this is not to scale at all, right? This 13 is only about twice as big as the 5, but take my word for it. Let's just say it's 13 units at $40, 5 units at $80. Let's further say, for the sake of argument, that we started with a price of $80 and we're dropping the price to $40. First thing I'm going to do is calculate the percentage change in price. The percentage change in price is based on this difference right here. The change in price is just the new price of $40 minus the old price of $80. All right, so we'll start there. Delta P, the change in price, is the new price of 40 minus the old price of 80. So the raw change is negative $40. Okay. Now, if you're going to find a percentage change, you need to divide this by some number to find this as a percentage of something else. And very often, percentage change, you take the difference between the new price and the old, or the new calculation or the new value and the old value, and you just divide it by the old value, which in this case would be negative 40 divided by 80 is negative 1/2. However, when we're calculating elasticity of demand, very often economists prefer to have the same measurement whether we're looking at moving from this point on the graph to that point, or moving from this point on the graph to that point. Okay? And that affects what we want to divide our change in price by. If I was going from a high price to a low, like I said before, divide this by 80 and you get negative 1/2. But if I was moving from a low price to a high price, in this case, it would be positive 40, right? The price would be going up by $40. And then if I divided by the old price, it would be positive 100% instead of negative 1/2. And so it is convenient to have a measure that doesn't change if I'm cutting the price or increasing the price. And so the way that we handle that is when we calculate percentage change in price, we divide the change in price negative 40, not by the old price, not by the new price, but by the average of the two prices. And that way the denominator is going to be the same whether we're raising the price or lowering the price. So take 1/2 and multiply it by the sum of the two prices. That gives us negative 40 divided by 60, because 80 plus 40 is 120. 1/2 of that is 60. So negative 40 divided by 60, we get a percentage change in price that's equal to negative 2/3, or negative 0.67. Okay? So that's the percentage change in price. Now we can look at the percentage change in quantity. And to find that, first we're going to need to calculate the raw change in quantity, which is right here, the difference between 13 and 5. All right, so the change in quantity is the new quantity of units we're selling at this new lower price, 13, minus the quantity of units we were selling before at that higher price, which is equal to 8. Now, if I want to find the percentage change in quantity, just like with price, instead of dividing by the old quantity or the new quantity, I'm going to divide by the average of those two quantities. And that is 8 divided by 0.5 times 13 plus 5. 13 plus 5 is 18, times 1/2 is 9. So I've got 8 over 9, or percentage change in quantity demanded is 0.89. Okay? Now that we have the percentage change in quantity and the percentage change in price, we just find the ratio between those two. And our elasticity of demand will be equal to 0.89 divided by negative 0.67. And then we're going to take the absolute value of that. So that just means this negative goes away and we ignore it. And that is equal to, if you pull out your calculator, it's going to be equal to 1 1/3, or 1.33 repeating. Okay? Now, like I mentioned before, the big consideration is this number greater than 1 or less than 1? In this case, you can see that it's greater than 1, and I'll discuss the implications for that in, I believe, the next video. But for now, let me move on to showing you that formula for elasticity of demand and spelling it out in its longer form. So elasticity of demand is percentage change in quantity divided by percentage change in price. This is the compact version of that formula. But you can also expand that out. This is percentage change in quantity. This is percentage change in price. Okay? So the way that you calculate elasticity of demand is take the new quantity, subtract out the old quantity, divide that by the average of the two quantities. Set that aside for a second, and then you take the new price, subtract out the old price from that, divide that difference by the average of, I see I made an error here. These aren't quantities. These are prices. P1, P2. Sorry about that. So you subtract the old price from the new price, then you divide by the average of the two prices. Then once you've calculated this ratio and that ratio, you take the ratio of the two of them. Divide the percentage change in quantity by the percentage change in price. Take the absolute value, so drop any negative signs, and what you're left with is elasticity of demand. All right? So that is how you calculate elasticity when you're dealing with demand curves.